Lesson 9-5, variation. Two quantities, x and y, are related by a direct variation if y is equal to a constant k times x. So formula y equals kx, that's direct variation. The constant k is called the constant of variation. When y varies directly as x, if there is some non-zero constant k such that y equals k times x, that would be direct variation. Now another form of that would be if you solve for the constant would equal x or y divided by x. So when you have a formula, you could see a formula that is y divided by x equaling y divided by x. This you would use to find the constant. But anytime you see y equals kx, that would be direct variation. The graph of a direct variation function, such as f of x equaling 4x, is a line through the origin. The direct variation is a special case of an equation in slope-intercept form of y equals mx plus b, your b just being 0. So that's why it crosses the origin. The slope of a direct variation equation is its constant of variation. If you know that y varies directly as x in one set of values, you can use the proportion to find another set of corresponding values. Blank or joint variation occurs when one quantity varies directly as a product of two or more quantities. So that's the difference between joint and direct. Direct just has one variable, constant or joint has two or more. So joint variation, y varies jointly as x and y, or x and z, if there is some non-zero constant such as y equals kxz. So you can see the formula, just x and y. For joint, you have x, y, and z. These are variables. So we're going to use the formula y1 divided by x1 equals y2 divided by x2 to solve these. Again, that is derived from direct variation of y equals kx. We're just solving for the constant. So here it says if y varies directly as x and y equals -3 when x is 24, find y when x is -16. So if this is your y1, x1, we need to find y2 when x2 is -16. So if I plug that into my formula, I would have -3 over 24 equals, need to find y when x is -16. And then I just cross multiply. So that gives me 24y equals -3 times -16 is a positive 48. If I divide by 24 on both sides, I now have y equals 48 divided by 24 gives us an answer of 2. So y would give us an answer of 2. Going back to second part, y varies directly as x and y is 21 when x is -5. Find y when x is 15. So again, I do the same thing, cross multiply. So this will give me -5y equals 21 times 15 is 315. Divide by -5, y would equal -63. Next, use this same formula to solve this one. So if y varies directly as x and y is -9 when x is 6, find y when x is -7. So cross multiply. So I have 6y equals 63. Divide by 6. I can keep my answer as 63/6, or I can do or I can reduce that. 63 divided by 6 is 10.5. Or you can put it as a fraction, which would be 21 halves. Either way are acceptable. Next, use the formula for joint variation of y1 equals x1, z1 equals y2 divided by x2, z2. How did we get that? If I have y equals k times x divided by z, I want to solve for the constant. I divide by x, z on both sides. And there you see how we got y divided by x, z. So y varies jointly as x and z. Find the y when x is 4 and z is -3. If y is -15 when x is -6 and z is 1. So if I simplify that, that's y over -12 equals -15 over -6, which will give me -6y, if I cross multiply, equals -12 times -15 is 180. Divided by -6, y is going to equal a -30. And the other one, find y when x is 14 and z is -6. If y is 18, x is 8, and z is 9. So rewrite this. This would be y over 14 times -6 is -84 equals 18 all over 72. Do cross products, so that's 72y equals -84 times 18 gives us -1,512. Divide by 72, y would equal -21. So when you have the formula, you're given the numbers, you can just substitute them in and it will give you an easy way to solve the problem. Check with this one, we need to find y when x is -4 and z is -5, when y is -135, when x is 5 and z is -9. So we have y over 20 equals a -135 over -45. So we have -45y equals 20 times -135 is -2700. Divide by -45. Y would equal 60. Next part is inverse and combined variation. Two quantities x and y are related by, this would be by inverse variation if their product is equal to a constant. So that means when your x and y multiplied gives you a constant. So x times y equals a constant, or if you think about it as y equaling the constant divided by x, that would be inverse variation. When y varies inversely as x and the constant of proportionality k is positive, one quantity increases while the other one decreases. You can use proportion as x1 divided by y2 equals x2 divided by y1 to solve inverse variation. Problems in which some quantities are known. An alternative form would be x1, y1 equals x2, y2. This one would probably be the easier one to use. For that one, I typically use this one more often than the other one. Combined variation occurs when one quantity varies directly and or inversely as two or more other quantities. If you know that y varies directly as x and y varies inversely as z in one set of values, you can use a proportion to find another set of corresponding values. So some formulas. If y1 equals k x1 divided by z1 and y2 equals k times x2 divided by z2. Then you can write it as y1 z1 divided by x1 equals the constant. And you can write it as y2 z2 divided by x2 equals the constant. So if they both equal the constant, then you have y1 z1 divided by x1 equals y2 z2 divided by x2. So let's use those formulas to solve. It says m varies inversely as n and m equals -4 when n is n equals 6. Find m when n is -10. We're going to use inverse variation. So I know there's no x's and y's, it's just n and m. So I need to do -4 times 6 has to equal -10m. So this is -24 equals -10m. Divide by -10, I would have m equaling 2.4. Next, if y varies inversely as x and x equals -5, when y is -1.1, find y when x is 2. So I have -5 times -1.1 equals 2y. So this will give us 5.5 equals 2y. Divide by 2. 5.5 divided by 2 gives us y equaling 2.75. A couple other ones here. Y varies inversely as x, and x is -3 when y is 3. Find out what y is when x is 18. So this is -9 equals 18y. Divide by 18, y would equal -1/2 or -0.5. Next, these are combined variation. So suppose A varies directly as B and A varies inversely as C. Find B when A is 6, C is 28. If B is 7, when A is 49 and C is 3. So to do this one, I would think of it this way. A varies directly as B and inversely as C. So now if I were to solve for the constant, it would be C over B, and over here would be C over B. So my formula that I'm going to be using would be AC over B equaling AC over B. So to plug those numbers in, I need to find B when A is 6 and C is 28. If B is 7, when A is -49 and C is 3. So I just plug the numbers in there. So now I do the multiplication. 26 times 6, or 28 times 6 is 168 over B equals -49 times 3 gives us a -147. Divide that by 7. Cross multiply. So 168 times 7 gives us 1176 equaling a -147b. Divided by -147. And b is going to equal -8. Next, here all the letters match up. So we need to find f when h is -12.6 and g is -10. When f is 20 and h is 4 and g is 15. So if I do cross multiplication, this is going to give us -12.6 times -10 times 20 gives us 2520 equals 4 times 15 times f gives us 60f. Divide by 60. So 2520 divided by 60. F is going to equal 42. Another one. So we need to find m when n is 20 and p is 25. If m is -4/3, when n is 6 and p is 9. So this one I would have 25 times 6 times m is 150 m equals 20 times -4/3 times 9 gives us -240. Divide by 150. M is going to equal a -1.6. And our last couple of questions are word problems. It says a rider's speed in miles per hour varies jointly with the revolutions per minute of the pedals and the number of teeth on the front gear, and inversely with the number of teeth on the rear gear. On a flat stretch of road, a rider is traveling at 17.1 miles per hour while using a front gear with 50 teeth and a rear gear with 16 teeth and pedaling at 70 RPM. Find the speed of the rider when she bikes uphill using a front gear with 34 teeth and a rear gear with 23 teeth while pedaling at 70 RPM. So the rider's speed, I'm going to use S, varies jointly. That means there's multiple multiple variables involved. So that's going to be our constant. With the revolutions per minute, so of the pedals. So I'm going to use P for pedals. So that would be with pedals and the number of teeth on the front. So I'm going to have F here, and inversely at the number of teeth on the rear gear. So we're going to do R on the bottom for the rear. So if I use this one to solve, I'm going to rewrite this so I'm solving for K. So I'm going to have K is going to equal the speed times the rear divided by the RPM of the pedals and the front teeth. So if I plug these in here, so the speed, so on a flat road, a rider is traveling at 17.1 miles per hour. While using a front gear with 50 teeth, so the F is going to be 50, and a rear gear with 16 teeth, so that would be 16 on top, and pedaling at 70 RPM. I'm going to have 17.1. This is going to equal, find the speed, so S, when she bikes uphill using front gear, 34 teeth, that's 34 on the bottom, and a rear gear of 23, so R is 23, while pedaling 70 RPM. That would be my equation here. So I would just do 16 times 17.1 times 34 times 70. This gives me 1225728 equaling, cross multiply on the other side, I have 50 times 70 times 23 times S. This will give us 8500 S. To get S by itself, I divide by 80,500. So 12,256 0.5728 divided by 80,500. We get the speed equaling, here we had like a little over 15, but there was a mistake I made by not reading carefully. It says revolutions per minute, and this is miles per hour. So we're not going to be using 70. We have to change 70 R per minute to hours. So that's 60 minutes in 1 hour. So instead of 70, we're going to use 4,200. So let me make that change very quickly. That's going to change what we have here. So in my calculator, we'll just put that all in here. So I'm going to do parentheses, and I'm going to do 16 times 17.1 times 34 times 4,200, end parentheses. And then we're going to divide that by the other side, which is 50 times 4,200 times 23, end parentheses. And it gives us the speed of 8.089. So if I put it to the nearest tenth, this will give us roughly 8.1 miles per hour, which would make sense if she's going uphill. She's going to go slower than what she'd do if she was going the other direction. And the last one, it says the combined gas law uses established gas laws to relate the pressure, volume, and temperature of gas. The volume V of gas varies directly as the temperature T and inversely as the pressure P. If a bag of pretzels is packaged under a pressure of 0.92 kilograms per cubic centimeters at 24 degrees Celsius and a volume of 980 cubic centimeters is occupied by air, find the volume of the air in the bag when the pressure is 1 kilogram per square centimeters at 29 degrees Celsius. So it says the volume varies directly as the temperature and inversely as the pressure of gas. So that would be our formula that we're going to be using. If we solve for K, this is going to be VP over T equaling VP over T. So if I substitute the numbers in, so if a bag of pretzels passes under pressure, so pressure 1 is 0.92. At the temperature of 24 and a volume of 980, find the volume in the bag when the pressure is 1 and the temperature is 29. So now on here, I'm going to take 980. So let's just do that on our calculator here. So I have parentheses 980 times 0.92 times 29, end parentheses, and then we're going to divide that by 24. That's going to give us 1,089. If we round it to the nearest one, so 1,089.4. So the volume would be roughly 1,089.4, and that would be cubic centimeters. So that is our lesson on variation.